Very pleased to be here and very excited that we're getting another GitOps Con kicked off. I will bowl straight in. The screen over here. There we go. So we are going to talk today, evidently about GitOps, but about governance and some of the extended things we can do with the GitOps Universal Control Plane. So, brief introduction. Hello, I'm Andy, CEO here at ControlPlane. We are a cloud-native security consultancy, and everything we do is just very good DevOps. We wrote the white paper Hardening Git for GitOps back in 2018, and have been deploying GitOps systems as the basis for all the security automation and DevSecOps that we have been doing for the last 7 or so years. I hold some non-profit roles in foundations such as Open UK, where we look to help advise, especially UK Gov, on open source, open hardware, and open data, and ideally avoid regulatory footguns. Coming years will be the judge of that. I'm lucky to have worked with some wonderful and interesting organizations. As I say, ControlPlane, we are security specialists. We have been doing containers since before they were cool, which is a very early Docker system back on 0.8 back in the day. And of course, we sponsor the open source Flux project, as well as providing an enterprise support package and hardened base images, and various other things, quality of life, data operations, enshrined into an operator as it's part of that extended package. We love the community. We have cut our teeth and learnt everything through these institutions, thanks to the Linux Foundation, the CNCF, especially there. And a few of the things that we've threat modeled over the years, eBPF for the eBPF Foundation, which is fantastically interesting. Of course, Argo CD for CNCF, and other pieces of work there, NIST publications, Envoy Gateway as well, and various links for some of the things that we provide around those, hardening Git for GitOps, of course, and then some reference architectures for how to deploy GitOps sensibly, both with and without OCI artifacts. So a quick overview of where we're going today. We'll look at the control plane concept from industrial control and Kubernetes. That's the mental model that we'll reuse. We'll revisit what governance looks like without GitOps, and that, spoiler alert, it is reasonably unpretty. Then we'll reframe GitOps, going beyond CI/CD into policy enforcement and compliance, control plane policy not just for deployments, look at real-world practices in regulated environments, and finally, explore where all this is going towards continuous governance as a first-class part of delivery. So the Kubernetes control plane, something we all know. Kubernetes introduced this reasonably simple but revolutionary idea: declare a desired state. And this, of course, comes from the work that Google did internally with Borg and the other orchestrators they built. And pray, set your hopes and dreams in prayer to a machine and hope that they reconcile into the state that you so desire. I have Tabby Sable to thank for that particular metaphor. And that's a deployment or service reconciled into what we want it to be and then maintained in that state. So if something is drifting from that state in terms of the low-level configuration, it is reconciled back. So a pod dies, well, the scheduler knows that pod should still be running and reincarnates it, rehydrates it. So this is not just another scheduling story. We were pushing things before that. This is a shift from imperative operations to intent-driven automation. And that concept, declare intent, reconcile automatically, is the same foundation that we want to use to bring governance into the modern era through GitOps, as we'll look at and present later. So why is this model so revolutionary? Well, it's a reduction in cognitive load, probably most importantly. With Kubernetes, you don't tell the system how to achieve that outcome. You just declare the desire and you allow that intent to transmogrify into an actual concrete system. And this alone slashes human error, especially when we're responding to incidents. Under pressure is the most difficult time to maintain cognitive clarity. And so these things all reduce the risk of running large production distributed systems. Secondly, it gives us safer automation. Reconciliation loops are always watching, detecting drift or partial failure, and automatically fixing it for us. This model scales beautifully as teams and systems grow. Imperative workflows with Snowflake deployments and customized scripting collapses under complexity. Declarative systems work because they scale by keeping intent centralized, versioned, and composable. This makes security and auditability default. Every change then becomes a commit, and every state is observable. And that is a commit in terms of append-only ledgers. Of course, we're now getting close to the Merkle tree of GitOps, and this allows us to prove compliance. It gives us audit trails. It gives us a view on what has happened over time that is not just trying to trace SSH sessions or reading through FTP logs from the good old days. And finally, this opens the door to the brave new world of AI ops. Now, we've recently released an MCP server for Flux. The Argo team have an MCP server. There's a few of them on the marketplaces or the listings. The strong recommendation from my perspective is not to run these systems in a mutable, writable mode. Gathering data, feeding it into context for a large language model, fantastic. We found 70 to 90% of the time, the response that the language model gives is reasonable. However, times when looking to rotate a certificate, it might be easier to delete cert manager rather than trigger a reload. Both of those things will get to the correct outcome. The certificate is rotated. However, one of them brings production downtime, and user compassion is not something that these models are yet developing. You will have seen that there have been attacks against MCP servers recently where it is not very difficult to abuse the unfettered, poorly RBACed privilege that comes with, say, the GitHub MCP from this week, in fact, and exfiltrate data. So again, the concept of AI ops is deeply enticing for many organizations. We very strongly recommend that the human remains in the loop, holds the liability, and does what they're good at, which is keeping production systems running. So where does that get us to? Well, if you don't have a control plane, we're in the manual, tribal, and unpredictable cognitive load, incredible risk of fragility, ClickOps, and what actually happens. Sometimes we have no idea. System state lives in somebody's head or in a Slack thread, and not embodied in code. Reviews are manual, inconsistent. We'll pass it today, may fail tomorrow, depending on who's looking. The resonant inductive coupling or non-determinism of the system, and environments will naturally drift. This is why we see configuration management all the way back at the origins of the cloud. So we bring governance to these processes. To define governance briefly, we're talking about the policies, controls, roles, and responsibilities, and compliance requirements that enshrine, embody, and provide an auditable and traceable list you can give to an auditor, we can give to your security team. In regulated industries like financial services, these are not optional requirements. We're taking access control and traceability, all of these incident response and secure by design expectations. And then as legislation is thundering towards us, we had Biden edicts, we have European Union legislation like DORA and NIS2. The pressure is only increasing. This is a good thing. We will see higher quality of systems, but it may come at the cost of fines to organizations that are not suitably prepared. So zooming out briefly, every organization has high-level policies. This is the boardroom of Dr. Evil, laughing at the quality of their policy enforcement from edict through to enforcement itself. And realistically, before GitOps, Comic Sans mess, these policies lived again, ephemerally, the policy is written down does not actually mean the techno-social efforts to get people to obey it exists. If the thing is enshrined, embodied as code, we do level that up slightly. We employ smart developers and they may still work around those things if the processes are not frictionless, but nevertheless, without automation and integration, governance remains aspirational, not operational. When there's no control plane for governance, things will unravel quickly. It's ClickOps again, tribal knowledge. That is the ball being thrown over the fence. I think that's the friendliest team to have returned such a deployment. Without a single source of truth, we don't have consistent environments. And when it comes to governance, the consequences are worse. We're talking everything from shadow IT to people reusing credentials and a lack of uniform application of what could be very expensive policy to fail to comply with. Audits become fire drills and not reports, and we end up submitting our compliance and governance as screenshots. So GitOps brings us to the universal control plane for everything. This is what fixes the mess. We extend the control plane concept into GitOps and we apply it not just to Kubernetes resources, but to everything else. Our application delivery, environment definitions, and most importantly, our security controls and policy. First, we start with intent. Tribal knowledge or config that used to be spread across tools is centralized into Git, a single source of truth, auditable, cryptographically verifiable, untamperable, and distributed. Now, centralized in some ways, but distributed in terms of collaboration. Next, from that peer-reviewed, versioned, and auditable data source, we have policy as code, collections of statements to express intent. And now that is actually encoded in a format that can be understood and enforced by policy agents. That happens automatically before or during deployment, admission control, and movement of those controls into our pipelines for fast feedback loops, and ideally even onto developers' machines where practical. Then GitOps controllers like Argo and Flux take over. They continuously reconcile the living state with what's in Git. If something drifts, if that resource was manually changed, it is reverted, just like the Kubernetes control plane. And this is how GitOps becomes a control plane, a governance layer that's continuously realigning reality with an organization's intent. And to that end, we've developed a small song that I will not do you the disservice of singing, but every commit is tracked in Git. Every change and deployment follows through policy. Every deviation is detected and corrected. And it's not just automation, it is control of these systems by an automated helper that is enforcing our state of the world and helping us every time we want to set those hopes and dreams to the orchestrator. If there is a change in that reality plane, they will repray for us. They will resubmit our requirements and intentions. This gets us to policy. We've built these baselines of automation, of enforcement. We know that we've reduced the risk of deploying applications. How do we define policy as code? Well, we take the things that our organization sets, and these are often linked to frameworks. We're talking maybe there's a NIST or a PCI, some form of compliance. Again, the deviation from which may cost us vast sums of money. And with GitOps and the cloud-native declarative paradigm, we declare them as code and enforce them automatically. From boardroom mandates to Kubernetes controllers, policy is now part of the pipeline. Git holds the policy, controllers enforce it, and policy engines like OPA or Kuverno apply guardrails for us. And suddenly governance moves from aspirational to executable. This brings us a deep sense of tranquility. One of the quietest superpowers of GitOps is actually audits cease to be stressful. Every change has a timestamp, a diff, and an approval trail in Git, exactly like policy changes on version control documents. We can recreate environments at any time. We can prove without question that systems are compliant, and governance is then a feature. So this isn't theoretical. This is where we're headed. Regulatory frameworks like DORA and NIS2 are raising the bar. We have the US DoD continuous authority to operate mentality in here. So even the most regulated systems can move through some of those structured regulatory hurdles. AI is also introducing additional governance needs. We must be cognizant of those systems. I'm sure we will hear a lot about this at upcoming Linux events, especially KubeCon North America, and of course the SecurityCon 0 day before that. If we want to meet and hit those requirements at scale, we need systems to continuously enforce. We need shift left in the pipeline. We need developers enabled to run these same static analysis or dynamic testing tools on their devices. End user device testing of production like controls reduces pipeline friction and ultimately saves us cycle time when we're pushing things into production. GitOps is how we get there. Not just about deploying YAML, it's about expressing organizational intent, enforcing policy, proving compliance, and bringing us that control plane for governance. And it's one we all have access to because it can build, and it is built on open source software and resources. So the key takeaways to rinse, and we've moved beyond CI/CD. We can now deploy anything and everything. GitOps has come full circle from infrastructure through to our applications and into our codified policy, versioned policy as code. We then have declarative versioned intent. We can even tag different policy versions and have different consumers compliant with whichever version. And then we upgrade a policy across a fleet of hundreds or thousands of clusters. And those applications that are unable to upgrade either get an exemption and go on a dashboard and then have business motivation, probably related to a remuneration in some way, to upgrade, or notification that policy is being upgraded gives the consumers an opportunity to upgrade before policy is implemented, along with a 2 or 3 version SKU, so that we can continue to move security forward without being a blocker, without destroying velocity or the speed of innovation for the organization. Policy as code, very, very keen on this, of course. Everything is auditable, traceable, and far more usable. Continuous compliance, governance at scale, and this future-proofs us because those applications complying to one version as it moves backwards have the opportunity to upgrade on a cadence that is more like what the business needs and less like what the security team desire. And with that, thank you very much indeed. I don't know if we've got any time for questions, but that is continuous governance with the Kubernetes and GitOps control plane. Thank you.
Thanks so much. Thanks so much, Andrew. That was really fantastic. We do have time for questions.
Very good.
Yes, there is a. I actually am getting used to the interface here, so I may rely on Ashley and Janelle possibly for where the Q&A can happen. But yes, does anyone have? You can. I think you can type your questions into the chat. Okay. Yes, there's one by Jason. I'll just go ahead and read it for now. I'd be curious to see how these principles applying to non-Kubernetes. I'd be curious how you see these principles applying to non-Kubernetes workloads.
The point that GitOps was presented to the world by Weaveworks, Alexis Richardson, the question that he often had to fend off on Twitter was, well, how is this different from configuration management? And you can see there are some differences. Configuration management generally was reaching out and configuring things. Of course, you can then set up some of those tools in a way that they're pulling. So there's one difference there. Another is the speed of reconciliation. When we're dealing with watch events on etcd, then GitOps controllers can move very quickly to change things that drift, etc. So in terms of, and then of course IAC sits in a similar bucket, but the cycle time to pull the information from the distributed system that is AWS or GCP or Azure is far longer. So ultimately, The cycle time is one of the biggest differences, but in terms of non-Kubernetes workloads, if we're talking about declarative programmable infrastructure or anything with an API from that perspective, it's just about how quickly does that cycle loop? Is there a requirement to maintain external state? Can I shoot the other node in the head kind of thing? So if we've got Terraform running or OpenTofu, for example, well, if you don't keep the state, you might be in some sort of trouble. So statelessness, reconciliation time, and the speed at which the loop can run broadly differentiate. But the principles can and should be exactly the same with those caveats. Some good questions as well. What's the best way for someone who's just starting out to practice GitOps on their own? There are some bootstrap kits. If you look at the open source projects, there are some wonderful playgrounds. You actually pronounce it. I think it's called Ixmuts Labs. I did reference the actual. There we go. Just if you look at the corner of that image, apologies for the size. There's lots of free playgrounds there, so you can go and play around there as well. And I think just to practice GitOps, it's also very much about how the configuration is laid out, because it is possible just to have one huge YAML file. Probably shouldn't even say that on this esteemed audience. But if your GitOps configuration repository is set up with customize and it contemplates what happens if I deploy from dev through to staging, maybe through to UAT, maybe production, or maybe just dev to production, at least then you've got the opportunity to set a smaller number of CPUs in dev on your laptop, set a larger number of CPUs in production on some hosted Kubernetes infrastructure, and really the philosophy of how configuration is set up locally is half the battle with GitOps, because it doesn't matter how you deploy it in production, it matters how you'll debug it or keep it under maintenance. And then please do stop me when we fit time. I'll run through a couple more. So extending the first question about these principles applying to non-Kubernetes workloads to different workloads like databases, reports, etc. Can they be considered with the same GitOps governance? And do you think non-Kubernetes workloads may take time for this to be accepted as organizational governance? Well, so I would I'll reference my friend Robert Reeves here. He was running an organization called Liquibase, which specializes in database transforms and migrations. The massive difference between a stateful and a stateless application is Kubernetes is designed to run application workloads that you can, there's this expression, shoot the other node in the head. It's actually a database expression. The idea is if something's stuck, you just turn it off. In that case, you pull the power and you have a background replication process that means the other node is able to pick up and carry on. Kubernetes optimizes for everything to have no state and maintain state separately so that scaling up and down is as easy as dealing with the inbound connections, terminating current work for that workload, maybe ongoing threads, and starting again, scheduling on another node. For databases, the risk of pulling the plug on a database halfway through a multi-column reindexing, schema transform, data load, it is huge. It can ultimately leave the disk in an inconsistent state. And because the database relies upon that disk so much, that could result in production downtime. Data is the lifeblood of every company. So from that perspective, the actual lower level work on databases must be done in a more considered and more human in the loop way than a lot of the reconciliation loop processes that I'm talking about, just because the risk to the business is so much higher. And then do you think non-Kubernetes workloads may take time for this to be accepted as organizational governance? It's broadly the same thing. If I can use infrastructure as code tooling and a load of providers to pull all the configuration of a client that I'm assessing or a system, then I can statically analyze that output and say, well, that's out of policy, because that is an S3 bucket with public access and no backup. Actually, there is a piece of work going on in the financial services open source community called Common Cloud Controls, which actually addresses some of these things. I'll just put the GitHub link in the bottom here. And the goal with Common Cloud Controls, there we go, it is actually to enforce that organizational governance as code and policy by providing secure by default Terraform components. And those components are linked to policies, and those policies are linked to frameworks. So you can say, I want to be NIST 2 compliant. Sorry, NIST 2. I want to be PCI. I want to be HIPAA. And these pre-baked providers will get you to compliance, but you do still need to run those loops where you're pulling the data down. If somebody's going through and clicking in the UI, well, it's very well to deploy it once, but if we're not rerunning our infrastructure as code tooling regularly, then there is a concertina, a window of risk during which something can change and we are in a drifted, non-compliant state. Just run through the rest of these quickly. Monorepo or separate repos, what's your experience? It depends upon the system. It depends upon the other people that we're working with. Certainly for the example architectures at the beginning, if you look through there, they are separate repos. Ultimately, Git is a form of security boundary at this point, and access control into those Git repos is a lot easier when they're decomposed. It also means that the RBAC for the deployment from each repo not only reflects the people who can commit to it, but you can also then drop privileges at deployment time. So individual repos tend to be a bit easier that way. Yes.
So yes, I think we are nearing time. I wanted to give you just a little bit of a heads up. Maybe I should have given you more, but
no, it's all good. I'll just I'll run through the last one here. You mentioned AI ops at the beginning of the talk. Curious to hear your further thoughts there on the impact or effectiveness of this new tool at our disposal. The interesting thing about an AI startup, in inverted commas, in this day and age, is that everybody has access to the same tooling. The tooling is now democratized. So if I want to start an AI business and Scott wants to start an AI business, we're starting from the same super advanced position compared to where we were 2 years ago. What we don't have is existing products, existing data, and existing customers. So actually, if we look at what's being shipped by AWS, by GCP, by Datadog, by Wiz, by Cisco, have just built something called Jarvis, which integrates with all the ServiceNow integration points. Those kind of AI ops where it's an integration with existing systems, the value is those existing systems. The AI ops is a sprinkle on top. So starting from scratch is an interesting problem. So speaking personally, we're going through a lot of threat modeling with AI-enabled systems, but we will always sign off with the liability on a human. And yes, plenty more to be seen. And I look forward to how the industry deals with it.
Great. Well, thank you so much, Andrew. Very enlightening, and it was just wonderful to have you. I'm really looking forward to following up on the conversation. Everyone, we can continue to do that in the chat, even as the rest of the day goes by. And if you don't know, for continued conversation, there is CNCF Slack. There's the Open GitOps channel there, where this kind of thing can continue beyond this as well. And I'll drop links in so I don't take up more time. Okay, thanks so much.